packet pushers.
Hello, and welcome to the Network Automation Nerds podcast, where we explore the latest in network automation from a practitioner's perspective. I'm your host, Eric Cho, a network engineer who loves everything about network automation. Today, I'm also joined by my co-host, Scott Robon from Total Network Operations. Today, we're honored to have Thomas McGonagle as our guest. With a keen eye for recognizing promising open source market-leading platforms, Tom is a leader in system management, leveraging his skills to solve his clients' most complex development, delivery, and platform challenges. Listeners of Packet Pushers would not be a stranger to Tom, as he has been on heavy networking and total network operations, talking about Git, CI/CD, and DevOps in the context of network engineering. In this episode, we'll explore Tom's unique journey at the crossroads of services and technology, discover how he identifies transformative tech solutions, GitNops, founding Kate's Coach, and so much more. Welcome to the show, Tom.
Oh, thank you, Eric. Thank you, Scott. Pleasure to see you both again. How are you guys?
I am good. I am good. I mean, I was fresh off listening to both of your episodes when you talked to Scott on, CI/CD and GitNops. So I was really impressed with your background, and I wanted to invite you here because I think there's more to be talked about. Anything to add to that, Scott?
There's so much more to be talked about. We really just scratched the surface. And I'd encourage anybody who hasn't listened to the first two episodes with Tom, please do. And as we get into this, Tom, like one of the things that I've been thinking a lot about are, for these DevOps type practices and tools, not everybody's in the same place and they need to move incrementally. And maybe you could think about that in some of your responses as we go. I don't want to impose structure on you, but there's a small, medium, large thing here, maybe even an extra large or 2x if you're talking about me. But yeah, just think about that as we go through the conversation.
I'm raising my hand right here on being incremental. I vividly remember I was talking to Michael Kennedy from Talk Python a few episodes ago about how I was part of the camp that was totally against Kubernetes. And I remember having lunch with one of my friends. His company is about to go public, and they were making a wholesale bet on Kubernetes to transform everything to Kubernetes. And this was like 2018-ish, right? It was puzzling to me. Why do you want to add more complexities? It's already complex enough. It's already fragile enough on the networking front. And you're putting in this virtual bridge. I mean, what the heck? Everybody knows bridge is bad, switch is good, right? So listening to, you guys talked about, and back to that context again, I think there could be a roadmap for people to get deeper into Git, for example, and then just talk about Git and nothing else on the operations around Git. How does it work? Why is it awesome? How can it help? And I think you have a great sports analogy on going from zero to hero on the theory of going down that path. Can you share about that a little bit, Tom?
Yeah, and so I think the first thing that comes to mind when you brought up the sports analogy, I played sports for a long time. I played college football, and as part of that, I did all this cross training and boxing and wrestling. Right, that was really kind of my background, and really kind of interested in sports. I'm interested in kind of self defense principles and practices and so forth. And so, what I've really kind of come to the conclusion of is that if you really focus on the stuff, whether it's Git or GitHub or containers or Kubernetes, if you approach it like it's a martial art and you approach it as a beginner and having this beginner mindset all the way to that black belt, that mastery, right? And mastery means a lot of different things to a lot of different people. But, what I'd argue, and I've talked about it with Scott before, is that you suddenly become basically a superhero. And I'm quite serious about it. Like in my Kubernetes journey, I often feel like I'm a superhero. When I have a task, it takes me a fraction of the amount of time that I would expect it to. And what's going on there, right? I'm this kind of experienced guy in IT, and I'm going along and I'm trying to figure out how long this project will take or this actual task will take. And then my guesses are so off. And what it is it's the tooling and the practice and having my history of my kubectl commands in my Z shell history. It gives me the ability to just quickly find these examples and get through these tasks at literally a fraction. And when I say fraction, Eric, I'm talking like I'll allot 4 hours for a task. It'll take me 15 minutes. It really is like this superpower. And each of the tools, GitHub, Docker, containers, and Kubernetes really do make me feel like a superhero or a martial artist or a black belt or Bruce Lee, if you will. So
Yeah, totally. Well, before we get into that, I think for people who are not familiar with your background and how to get here, can you just tell us a little bit about yourself? Maybe you could share with us your philosophy on, sports as you did just a little bit ago on, playing 8 years of varsity. And I wish I did that, but tell us more about it. Tell us your background, how'd you get here, and how'd that tie into who you are today as a technologist?
Yeah, so for me, the philosophy of sports really comes down to that practice, 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 and then when you're done practicing, practice some more. So when I was in college, it was Division II football, and people don't realize it's only milliseconds slower than Division I. It's really very fast football. In high school, I was a wrestler, and so those skills were the cross training that I did, and they were very, very helpful. And so I was basically always practicing for the football field, the gridiron. And then in college, I had to transition to boxing for the speed, and so in college, I jump roped 2 hours a week. It was 4 half-hour jump ropes. So I just worked on my foot speed, night and day. Not night and day, 4 hours a week. It's not night and day, but it was a lot. Jump roping for a half hour, 4 times a week is a lot. And
It's high
so
intensity. Yeah.
My calves ache right now just because you said that. Yeah.
at the height of my football career, I was like, I could bench press 500 pounds. I was a left offensive tackle. It's a very difficult position. People are kind of aware of it from that movie, in the book, in the blind side. Yeah, the
Yeah.
blind side, right? You're protecting the blind side. And so it's a very difficult position. And your opponent are these like absolute psychopaths. They're the axe murderers on the other side, right? So you have to like be ready to take on an axe murderer.
Right.
The way you combat that was just practice, practice, practice. I've taken that mentality throughout my career. So, I'm always practicing. I'm always looking for ways to do things better. I mentioned that Z shell, storing my Z shell up in the cloud so I always have access to it. Like there's all these little tips and tricks that I've developed. And that's very much a sports analogy. As you go through football, you kind of figure out these little tips and tricks and how to beat the opponent, right?
So let me ask you this, Tom, because you're this D2, athlete and play at a very high level. But for someone like me, who is just maybe very rudimentary on my football skills, I don't know how to tackle and I don't even know the rules, right? Where can I start coming back into technology? Is it Git? Is it container? Is it Kubernetes? Where should I start?
Yeah, so you mentioned that I was like a varsity athlete for years. That's actually not true. So my freshman year, my sophomore year, I was a bench warmer, right?
Okay.
And then hitting the weights is what did it for me. So I was able to get quite strong. I could bench press 300 pounds my senior year of high school. And what I'm suggesting, and the analogy I'm making for hitting the weights is Git, right? Developing some Git skill, getting some Git skill. And, I'd love to give you kind of a brief overview of the history of Git. I think it's important for people to kind of appreciate. And so the Linux projects was going along kind of handsomely, and they took on this BitKeeper content management system, so a version control system called BitKeeper. And then there was this character who was one of my personal heroes. His name is Andrew Tridgell, and he invented Samba, if you guys remember Samba, and he
Hmm.
invented rsync. I use rsync all the time. And so he invented rsync, and he was poking at BitKeeper via telnet. He was like poking around the API, and that got the Linux project into trouble. So Linus Torvalds actually created Git, and Git has all these, like even to this day, all this like influence from Andrew Tridgell in rsync. It's basically the syncing protocol that takes a distributed version control system. That's what makes Git so popular and so important. Is that before that, everything was just kind of stored up in the cloud, right? And then you couldn't work on the Linux kernel on a plane, right? That's always been like the big differentiator with Git. You have this local copy of the Linux kernel, and you can work on it on a plane. And then when you land, you sync your changes, and then like the version control system kind of takes over and makes it possible. But people don't realize this, but Git is like a file system. So you have a file, and then there's like a change to the file, and that change is really the delta. And then it works like a file system that comes from, Linus Torvalds, who, has a lot of experience with file systems, and Andrew Tridgell and others that really started working on it. But I just wanted to say that I think the best thing you could do is get really quite good at Git. And TNOps with Scott, I said, you can store anything in Git. You can store Word documents. You could store Excel documents. Like that version control capability is applicable to your personal life too. And so jumping into Git is useful, right? That's my argument.
I agree with that. I don't even have to go very far, right? The first time I step into, the Microsoft building for Windows, I see all these development cycles. And I do remember the time when the code base has to be centralized on a server. I mean, you say cloud, but it just has to be centralized somewhere, right? That is reachable. So, I mean, you check out bits and pieces that you work on, you quickly go back into the mothership. Otherwise, you lose that change and somebody else will overtake you and whoever checks and wins, right? And in a
Right.
way, like that's how Git works as well. But I think at this time we don't need to get into the details of like the MD5s or the hash values and so on. But let's just take it as Git magic, where they are able to take a large project, have local copies everywhere, and somehow synchronize them and in having a coherent code base that everybody could agree on. Is that an accurate description?
When you talk about that synchronization, like talk about the conflict management issues and how they're resolved in when I come up with the product.
The typical workflow, and it's called like a GitHub flow, is that you have this one code base and then you create a branch, and then that's your working branch. And then everyone on the teams, let's say it's a team of 10 people, they have their own working branch and everyone's kind of going along. And then the magic that happens is when you fold them all together back into that mainline branch, right? And those conflicts get resolved through a collaborative process. And for example, this is a good segue into GitHub. And that's really what GitHub provides, right? So I worked at GitHub and I don't have any allegiances anymore to them, but just for sake of, I'm a very old user. I was like in the first group of users in 2009 that joined the company. My GitHub handle is my last name. That's kind of an example of how I was able to get in so early. And what GitHub does is it's a social coding platform, and so it manages those conflicts that Scott was referring to, and it manages them via this concept that GitHub invented called a pull request, which is a request to pull in the changes. And then you have to go through this kind of process of kind of working out the conflicts with your co-collaborators on the repo, on the project. It works extremely well.
I think that's a great point. So in the original form, when Linus created Git, there's no centralized branch, so to speak, right? Like there's no centralized server for everybody to synchronize to. Everybody could be starting Git init and then having somebody else synchronize them. And perhaps his laptop is the source of truth, but technically anybody could have their Git branch and Git code base. However, what GitHub does is to say, okay, we'll just business wise, team dynamics wise, it's easier to have a centralized location. So let's make this cloud based SaaS place that's everybody synchronized to. That's a central location for everybody to, pull down their copies, contribute it back in, and so on. And you mentioned some of the different terminologies on what GitHub provides. Part of it, as you talked to Scott about, was the forking, right? So you have the centralized copy. And if you imagine that your workflow is, okay, now I have to go work on some route configuration, for example, I need to somehow pull it down and then make my own local changes, push it back in a safe and organized, pragmatic way. How does that workflow look like, Tom?
You have this repo with a router configuration in it. And
Right.
then Scott comes along and he logs into GitHub, for example, and he logs into GitHub with his credentials. And then he goes to that repo and he clicks up the rightmost button in the top right. And it's a fork, which is a copy, but it has connections back to the original repository. So Scott, if Eric were to make changes to the original copy, Scott would be able to pull those in and then keep working and kind of manage those conflicts. And so now Scott has a copy. It's a quote unquote a fork of the project. And then Scott wants to make a change. He changes the VLANs assignment, or if it changes something kind of specific about that router configuration, he makes that change. He saves it. He commits it to his repo, and then he creates a pull request. And it's a request for you, Eric, in the original repo to pull in the changes that he made. And then you review them and you say, I don't think that's the right tag. All right, whatever it is, right? You can have this coordination. And that's all done through a GitHub issue. And so you have this pull request that's attached to a GitHub issue. And then there's the code that was changed, this Delta, and that's attached to the issue. And then there's a pull request that's associated with the issue. And then you guys can coordinate and configure and manage that change. And then just imagine, I just want to call attention to this, guys, like the visibility it gives into the configuration management, right? And so this is a common workflow, for software developers to make changes to XYZ, right? And so what I'm suggesting is that this is a beneficial thing for network engineers to collaborate on their configs and get second or third or fourth sets of eyeballs on a particular config change. Mhm.
That is a great point. So the accountability portion of it, I want to also touch base on all the changes and all the things that you check in and you worked on. Those are immutable, right? So can you tell us a little bit about the immutability? And even if you rebase it or revert it, right? Like those changes you don't lose those changes. You just kind of see the wheel moving forward into those previous check-ins or whatnot.
Well, that's a great question. I've never really kind of thought about it in terms of like a network configuration. But let's say Scott does make that change and then you disregard it. And so that change is not lost, right? It's still in the queue. But what you basically do is you kind of just don't accept it. And then you make changes. And then Scott would have to park, his change that he made in his code base because it was rejected, right? And so he would do like a git stash, right? Which would stash those changes away. And then he'd be able to do another pull request to pull down your changes because you've been actively working on it. It would pull in your changes, and then you're ready. Then he's ready to go to try the correct VLAN. You guys have collaborated, and he's made a change. He's made a configuration change to it, and now he's ready to submit a working copy. And then he sends another pull request to you, and then this time it's approved because it met your standards. But you're right though. It's like a wheel that just keeps turning, right? Like you're not throwing away changes. It's recorded. There's a history of all this work. You would get credit for it, Scott. You made this change, right?
Yeah, anything you need to add for that, Scott? I mean, how do you feel about just being a stash away?
I feel like I've been given way too much credit here. So thank you, Tom. You've literally made me the big boss on another episode. So, you're too kind. So I don't want to be a contrarian, but kind of ask how these things fit together. Now, it seems there's the review of changes process, right? That Git
Right.
facilitates, but there's also, approaches to conflict management. So for example, if I'm dealing with configs of routers and switches in my network, I could say, well, this neteng, person X gets to deal with site 1, person Y gets to deal with site 2, and no one else should be changing any of the files associated with those routers. Or I could say, well, there are people who are doing the access config and doing VLANs for multiple sites, across multiple routers perhaps. And then there are somebody else working on the BGP config for those routers where I might have multiple people modifying that router config, even though it might be templatized pieces of config. How does Git help me, deconflict, keep person X from configuring over person Y where it's appropriate?
This is a terrific question, Scott. So where my mind goes first is, let's say we just keep with your scenario where person X is in charge of this portfolio, person Y is in charge of this portfolio. So let's say that's still a perfect use of Git, right? So what do you get if person Y and person X are just using Git to manage their stuff? Well, it's documentation, right? There's actually reassurance, right? And that's kind of a funny word for documentation, but there's actually reassurance that happens by just storing in Git. And then you don't have to worry about losing those configs if they were on the person's private computer or whatever. And so they're stored in a centralized place. The rest of the team can access them if they were on vacation or if they left the company or whatever. Kind of thinking about that some more, I lost the other part of the reassurance. Anyways, and then so the other thing that you kind of brought up for me is like with like a tool like GitHub, what it provided was the really wonderful RBAC that it provides on top of the Git repo, right? So you have these different roles and you have these different groups and you have these different privileges for the different people to do various things. And so, I'm not saying that you're assigning privileges for people to push out the configs, but I'm saying you're assigning privileges on who gets to make configuration changes and why and when. But maybe you want every intern in the company to be able to read them, right?
Yeah.
Just so they could read it, right? And so, but then you only want people at a certain level to actually be able to actually modify. And so that's all capabilities that are built in that weren't necessarily built into the original Git. The original Git used the Linux userland user groups privileges, right? But
Yeah.
but GitHub gives the RBAC, right?
Yeah, I mean, I've known crypto trading companies where the algorithm, the code base is their secret sauce, right? There's the know-how,
Mm.
right? So each of the engineers could only check out the portion of the code that they're authorized to modify on. And they will give it like a temporary code to check it in. And they will be watched over on say, this is not the branch or this is not the portion that you're supposed to check out, right? And then they will signal your log and so on. So the accountability piece of it is really key, the RBAC that you talked about. All of these was not, the forking, the branching, the merging. They were not necessarily the original Git invention, but these are all the extra stuff that the platforms such as GitHub and GitLab provide you with, and like the role-based authentication and authorization type of services. So I think what you mentioned, just going back to your example, Scott, on you don't want anybody to merge it, so maybe only the senior engineer is able to take a look at the config on, me, the junior engineer, have written, and I'm promoting you again, Scott, on that you be able to say this looks good and I'm going to merge it, and it's all documented, right? So no longer is the production device is the source of truth on, hey, I don't know why this VLAN tag was there, but it's working, so it must be good. I could go back to Git and look at all the history and say, oh, that is why it was made that change. And perhaps that was just a temporary fix. And God forbid, somebody forgot to go back and revert the changes. So all of these are documented, role-based, and you could go, as far as having just a portion of the router config being checked out.
So what's that router config being checked out, modified, checked back in? It seems to me that what we would call production means placing the final config or config snippet on the network device, which is an analogy that doesn't hold for just software, not directly anyway. Where does what you called accountability, Eric, we also couple with responsibility? Does Git give us the tools to say only these people can push these configs to the production devices, or is that a layer outside of GitHub?
I would say that's a layer outside of GitHub, but let's hear what Tom has to say.
Yeah, no, I completely agree, Eric. It is commonly referred to as continuous delivery in like DevOps, right? I think this came up in our previous talks, Scott, that DevOps is made up of people, process, and technology. It's not just technology, right? And the people and process are just as important. So what you're describing is like, what is the process? Maybe the process is that someone does a sneaker net. Let's say it's like an air-gapped environment or something. Someone
Sure.
literally does a sneaker net, from GitHub and copies the configs onto a USB drive, then brings them over to the Linux machine in the air gap, and then uploads them to the router or something. But that's a process, right? That's
Right.
arguably continuous delivery. It's not continuous delivery, but it's delivery, right?
Sure.
I think what you're describing is really kind of a process problem, or a process choice.
Yeah. And that's absolutely a fine answer, right? Delineating here are the tools that Git brings to the table, and here's the process wrapper that you need to govern what people actually do. See how I work people, process, and technology all into the same sentence there. So
Mm.
Kudos to you.
I'm trying.
Yeah. So I would definitely think of that as a different process, as you said. Now we're, kind of couple it in, right? So we started with Git. And I guess the next process that or tool that we talked about implicitly was kind of the add-on services outside of Git, the technology, the GitHubs, the, nerdy collaboration, the social coding piece, having the RBAC, for example. So outside of GitHub, on top of that, we have the CI/CD process, and that's what you guys talked about a little bit. Do you want to give us an overview on that, Thomas, on what CI/CD is? And we don't have to repeat everything that you guys talked about, but maybe just an overview.
Yeah, so continuous integration and continuous delivery are important parts of software development. And continuous integration is where you build and test your software. And like, there's nothing more important in network engineering, I'd argue, than how important testing is, right? And so you build. It's a building refers to like a Golang program being built, compiled, or like a C program being compiled. So that's really kind of software specific. And so there really isn't that step, the build step with network engineering configs, but there is, the secondary step of testing, right? And so whether that's some sort of test harness, whether it's to be container lab or whether it's a digital twin, whatever that looks like. So you have to really kind of test it. And then the second phase is delivery. And delivery is actually getting it into production, right? And so for production, it's, updating that router, right? Updating that switch, to its latest configuration. And that could be a process. That could be that sneaker net. That could be, someone copying the config file, or running it from their local repo that they have on their local machine, on their Mac or whatever, and SSHing into a switch and uploading that config, or running the commands individually that are mapped out in the config. I don't know. I mean, I'm sure that people have opinions about doing that, but it's really just getting it out the door. That's what it really refers to.
Yeah. So if we were to overlay the sports example that you brought us before, a white belt is, just doing everything manually, right? Where do you place the next level on, maybe yellow and blue and so on?
Believe it or not, I'm going to hedge my answer. An orange belt would be something like using project management. And so I often think of this kind of sphere of software principles applied to network engineering as agile networking, right? And I think using Scrum approaches to managing the network is really that next step. And that's, by the way, built into that documentation and the reassurance that you get with GitHub. They're actually, those issues that I brought up before can be organized into a Kanban project board inside GitHub. It's called GitHub Projects. It's a very nice project management board. For me, the next level up is actually applying more management processes to the projects, to the coordination of that networking and getting that out the door. And so, like I said, I'm going to hedge my answer. I'm introducing kind of a new layer, and it's project management.
That's a good point. But typically in network engineers, we're not, doing stand-ups every day. We're not very familiar with agile and scrums. So can you give us a little bit? I mean, since you're hedging your bet, it's only
hmm
fair that I ask you to do an overview of these new processes that you introduced. What is a scrum? What is agile?
Agile refers to kind of the opposite of the old way. For the first part of my career, I worked the old way, and it's called a waterfall software development methodology. And that project management methodology had kind of an analysis gathering phase, and then a development phase, and then a testing phase, and then a deployment phase. They would happen like a steps, like a waterfall. And they were
Mhm.
very, very long. And there was a reaction to it in the software development industry that was taking too long. And by the time you actually deployed software, the analysis that you did 6 months before wasn't relevant anymore. And so at a wholesale, it's been taken up by many, many software development shops. They took on this idea of agile. So they're no longer doing these long, long lead times. And, by the way, my bachelor's and master's degrees were in systems analysis and design, which is like a dead thing now, right? But it's helped me out tremendously throughout my career. It really provided this systems thinking background to kind of approach all these different things. It's something that Scott and I have talked about, just the importance of systems thinking. But this systems analysis and design was kind of jettisoned from the agile approach, right? So now people just kind of have these 2 week sprints and they say, let's throw spaghetti against the wall, let's see what sticks. And they work on a project for 2 weeks. And then if it was successful, they keep building on it and building on it and building on it. They're course correcting throughout these 2 week sprints. And what I'm really describing is this Scrum approach. And Scrum gets its name from rugby, the Scrum where everyone kind of bandies together into this one little huddle and they push the ball forward. That's really where the name comes from.
Oh, I didn't know that.
It's
Yeah.
another sports analogy, right? Yeah.
Another sports analogy. Yeah. I love it.
Yeah. One of the things that's really important about Scrum is they have these little stand-ups every day. And I do think that network engineers could benefit from it. And all they do is every member of the team goes around and says what they did yesterday, what they're doing today, and are there any blockers? And I find that an incredibly effective way to gain visibility into what's happening throughout the rest of the team and what's going on. And like in these Scrums, people will solve actual problems, that I'm being blocked by, XYZ. And then they say, okay, have you tried this, this, and this? And they don't know, okay, I'll try that. They're able to unblock themselves. It's very, very useful.
Now, since you raised it up from the process and people perspective, why is it called a stand-up meeting, Tom?
Yeah, everyone stands up for it. Back when we had cubicles, right, before COVID, everyone stands up. It's a 5-minute meeting where everyone just stands up from their desk.
Keep it short.
Keep it short, yeah.
Because so many of us suffer from meeting fatigue. And again, I know this is not a tech issue, but that quick check-in at the beginning of a day, with what am I doing? What blockers do I have? Or nothing to report. You sit back down as soon as you're done.
Yeah, and I think it's important to have that time bound because we know we're going to come back tomorrow morning and we're going to do the same thing again. So if I say this is what I'm going to do today, Scott or Tom, you might tell me, "Hey, I think you're too ambitious, right? Like that's not going to be able to accomplish that much stuff in this short time frame. So therefore you need to cut it down and so on." So I think this collaborative process, I mean that human layer on top of the process is really important as well for all of us to just be more empathetic on what other people are doing.
Yeah, I think that's a great point, Eric. I'd argue that the utilization of like a GitHub plus the project management plus the stand-ups will breed more empathy, and like I'm not even just talking on the network team. Like I think if you're adjacent to the software development team and they overhear it, or they're a part of it, or the database team, or the security team, they're going to be more empathetic, and you're going to be more empathetic to them. And my vision for DevOps was always this coordinated team of specialists, right? Database engineers and network engineers, coordinating together. And I think that's a really critical aspect of this stuff. Is this agile networking? I think will increase empathy.
Yeah, I agree. So I love the fact that we're building on top of each other, right? So, we started out with nothing and then we have the technology of Git. Now we have processes surrounding Git that built on top of it, but enhancing them for whatever we need at the enterprise level. And for the Git to actually take effect that we have the CI/CD process and pipeline, the agile, the move fast and hopefully not break stuff, right? But moving fast. So when moving fast, we obviously need an automated process too for the runners perhaps, or for any kind of execution scripts or whatnot, and those cannot be executed manually. Is that where kind of Docker comes in? And so now we're going to introduce another component to it, or do you think there's another layer in between that we need to talk about?
I think I'd be reticent not to kind of bring up that the Linux distros are all moving away from like the traditional package management systems. They're moving to containers, right? I work at SUSE, a Linux vendor, and that's going to be our approach. And these containerized tooling is going to be a prominent thing. I think a background and an understanding of containers is really quite critical. And I've noticed that in the network sphere that there are applications that are coming out from vendors that are containerized, and it's happening more and more. And like even if it's just like a little CLI tool, they containerize it and you run it from your Mac, your Windows, or your Linux machine, and you do X, Y, Z. I've honestly noticed that, but if it's okay with you guys, I'll just define containers very, very quickly. I'm proud of this experience, but I was at Red Hat Hat working on OpenShift, the original. This is like 2012, 2013, and this is before Docker came out. And I was there when Docker came out in March 2013, and then by September of 2013, Red Hat was like partnered with Docker. They said, "Well, this is way better than what we were doing." What it was Docker back in 2013 took two very, very important kernel features. One was called namespaces, and one was called C groups. And what they do is they segment an application and they basically cordon it off so that it appears almost like a virtual machine, but you don't have the overhead of a hypervisor, right? And so it's very, very powerful. And we've seen tremendous things happen. And then it's the food that kind of powers Kubernetes, right? And I'm sorry to bring it up prematurely, but Kubernetes schedules Docker containers. I can talk about that in a minute, but this containerization is just so, so important. And it's going to become more and more important. Like the tooling that you're going to be using going forward, I think will be more and more containerized.
Well, maybe just because I've been obsessed about containers that everywhere I see are containers now, right? Like Container Lab, and we have containers that you can launch on iOS platforms, iOS XR, XE platforms, and so on, air gap environments, and so on. But I wonder if that's the case for other parts of networking. Scott, what are your thoughts on that? Is it just me like looking at blue cars because I have a blue car?
Mm.
There's a name for every kind of bias, right? So I don't know what
Yeah,
kind of bias you're referring to.
ownership bias or
Yeah, there
yeah.
you go. So I would take this from a different perspective. And since this is network automation nerds, and the first word is network, the experience of network engineers with first virtualization and then containerization is a really mixed and interesting history. I won't go into it in detail here, but early on, we saw this push for, can you take your router operating system and wrap it up in a VM? And that was interesting, but it was big and clunky, and let's just say had limited success. There's this whole carrier movement called telco cloud that still relies on virtualized router and switch operating systems. But some people have this really weird, oh man, yeah, the whole VM thing just really was kind of messy for networking. And then the way we were introduced to containers was, hey, here's a lighter weight and more flexible way to package an operating system and its components that doesn't require the whole operating system. It can still depend on libraries that are in that Linux distro and so forth. So that's kind of, I don't want to say your average network engineer's thumbnail sketch of virtualization into containers, but I think that's fairly common amongst lots of network engineers.
Yeah, I mean, I think I would agree to that. On this migration process has been long, and because of the unique challenges for networking and its baggage, if you want, for the history of it, that we're kind of slow to the game. But now we're here, and I think container is here to stay. Whether it's the legacy vendors or whether it's the vendors that are coming up that are embracing containers, then those are kind of wait and see on where that's going to go. So I want to get back to what you were talking about, Thomas, on differentiating between, and part of what Scott talked about, differentiate between a VM and a container. So for someone who is familiar with a VM, because VMs are older, on the hypervisor that we talked about, differentiate that with containers. What are the advantages and what are the disadvantages it coming from a VM background?
With a VM, you have like this server that you're going to install the VMs on, and you have to install a hypervisor. And so there's a hypervisor that comes with Linux, right? It's called KVM, kernel virtualization machine. And there's also like VMware, right? VMware has their own hypervisor. So there's like this little thin OS that has like a full-blown OS on it to run other virtual machines, right? And then you take like an ISO image of Linux or like a USB stick or a CD-ROM of Windows or whatever, right? And you're able to install these different OSs. And those OSs have the second overhead, right? Like you're just trying to run an application in that VM, in that Linux VM, but you're installing all the operating system stuff to run that application. And so conversely, containers provide is this like little small slimmed down application, and then you're able to run it on the Linux host. So you're not running that hypervisor, you're not running that second OS, and you're just running this application stack. And that application stack can be extraordinarily complex. For example, and we keep talking about Container Lab. Like the Container Lab has been able to get from all these if I understand it correctly, keep me honest, guys. They've been able to get all these different OSs, this network operating systems from all these different vendors as a container, and they're able to run them inside of the container stack that like Docker provides. And it's just marvelous. It's an opportunity to create that test harness or to learn, right? I think its original purpose was a kind of a learning environment for people, right? And that's all really kind of possible through this. I think last time I looked at Container Lab, it was supporting like a dozen different NOSes, right? That's all kind of provided from that containerization of those NOSes. But if the converse of that would be 12 different VMs and having to run those and manage those and spin them up and stuff, I don't mean to put words in Scott's mouth, but I believe you described it as clunky, right? It is clunky. When I worked at F5 Networks, I worked on their virtualization
Sure.
image, and I ran it in AWS. I did all sorts of fun. I taught people how to use Ansible with it, but man, it was clunky. It was expensive. It cost me a lot of money every month to run that virtual machine. But with containers, we can look at Container Lab. The benefits are extraordinary.
Yeah, I've seen memes online where somebody asked the poor fellow on, maybe they just appear to be, not having a home or, just kind of having a hard time in life, right? And then somebody will ask him, so what happened? And they're just like, I left the VM running in AWS. Or something like that. So joking, right? Don't write me angry letters or FUs on follow-ups for that. But yeah, back to your point, it's resource intensive, and to be fair, I think if you look at the NOS that are container lab supportable, some of them are VM converted, right? So it still has a downside of more resource intensive than a native container based NOS. However, it's getting there. The more and more Arista, for example, there's the CEOS or the containerized EOS versus the VEOS, the virtual VM based EOS, and also, obviously the bare metal ones. So I think it's getting there. And so now that we're on the subject of Docker and containerization, of course, the next level would be how do I manage all these containers? Because it's so easy to spin one up. Now I have a dozen, right? I work for Network to Code, and in order to launch like a Docker Compose Network to Code, we actually have 5 different containers running just to support, this one app with, the databases, the Redis, the scheduler, the salary workers, and the Nautilus itself, and so on. So that becomes a nightmare. And is that where Kubernetes comes in? And Container Lab has like Kubernetes version as well, but we won't get into that. We'll just go to Kubernetes next.
Yeah, yes. I think you nailed it with that example. So in that network to code example, you have a database and you have the application code and then you have the messaging queue code. And so you have like 5 containers, right? And so what Kubernetes does is it allows you to manage those 5 containers and network them all together so that they can communicate with each other, right? What's the point if the database can't talk to the application code and so on, right? And so
Right.
it networks them. And then, I used this word before. It's a funny word, but it schedules them, right? So Kubernetes is a cluster technology. And if anyone out there is familiar with like high performance clusters, they're highly available, they're reliable, they're scalable, they're available. There's all these ables, right, that they provide, these clusters of servers. Back in the old days, we used to have mainframes. And then Linux was able to kind of focus on this high performance cluster market and provide all the capabilities of a mainframe, but a much more inexpensive kind of form factor. So it's a cluster, right? And so you have all these different machines. The pods, the database is a big, huge pod, right? The pod is a name that comes from a Docker container. So it's a group of Docker containers. And the logo for Docker has always been a whale. And so a group of whales is a pod, right? And so the Docker pod, it needs a lot of resources. So it needs to be on the biggest machine, right? And then the application servers, we need to have like 40 of them, right? The network to code application is so popular, it just needs 40 pods, right? 40 containers running in 40 pods. And so that would schedule them across all the different machines. And then there's a load balancer component, and that's actually kind of built into Kubernetes, depending on where you're hosting it. But you can do all sorts of kind of different things if you ever heard the word ingress. And then there's all these other pods that need to be scheduled and need to be managed. And what Kubernetes does is it keeps them healthy, right? So if there's a problem and it crashes, it'll restart it. And like it does all that high availability, reliability, scalability, kind of capabilities.
Yeah, I like the fact that we're building up on that. And, just by extension, I want to mention that Container Lab has a new project called Kubernetes. So it's, Kubernetes managing Container Lab. And there's a great heavy networking episode that we'll put in the show notes if you want to hear more about from Carl and Roman on that project itself. So I like the fact that we're building on top of that, right? So we have Git, we have, surrounding GitHub, for example, the surrounding services, we have the CI/CD practices, then we have, Agile and more procedures around those processes. Now we're executing via Docker, and to manage these Dockers, we have Kubernetes. Are we finally like black belt? I'm so tired just like thinking about all the processes that we have to go through and all the work that we have to go through. Are we there yet?
I would argue you are.
Okay. The superpower.
The caveat is that there's like a bunch of stripes you can get after black belt, right? Like there's like sixth
Yeah, yeah.
degree dawn and karate, and like there's always more mastery you can work on, right? So I would argue if you get your hands around these 4 buckets, I think you'd be in really good shape.
If we need help on Kubernetes, is that where we could find a Kate's coach or
Yeah. Thank you. That's a great segue. So an initiative that I'm doing is Katie's Coach, right? So it's Coach with a K. So Katach. unleash.com. And I'm here to help anyone reach out. Actually, my good friend Scott and I are going to be doing some Kubernetes the hard way after this meeting, right? And so, I'm looking forward to that. And if anyone's not familiar with that, that's a tremendous project, and it really gets you into the nitty gritty of how Kubernetes works. And it's really quite helpful to kind of understand it. It is the hard way, though. There are much, much easier ways, but there's a centralized database that Kubernetes uses called etcd and exposes you to that. And there's the DNS system that Kubernetes uses called Core DNS and exposes you to that. And I really highly recommend it. And kind of the godfather of Kubernetes invented it is a guy named Kelsey Hightower. Kubernetes the hard way.
That's great. I mean, I've actually taken classes like Python the hard way. And what they meant is the hard way is the easy way, right? Because you need to go through the nitty gritties, down to the earth details where rubber meets the road. And then you're able to, just like if you could bench press 500, now 200 is nothing to you.
Right.
Do you like how I bring it back into the sports analogy again?
Oh, it's amazing. Yeah, that's brilliant. I love it.
Yeah, and we throw down so many terms and technologies, and hopefully we give like a roadmap for people who are looking into learning all these technologies. And Scott, you actually brought up a good point during our conversation offline about, there's a couple of interesting LinkedIn discussions on, how do we get to the next level, or, can you tell us a little bit about that?
Yeah, I think there's a set of common discussions for network engineers on what's needed for today's network engineer to be ready for not just the future, but now.
Mhm.
And there's a few common themes that keep coming up, right? And one is understanding Git and GitHub in particular. One is you need to understand some Linux, right? And if you've got other Unix variant experience, don't worry, Linux is going to be an easy pickup for you. The man pages are your friend. Python is another common tool that keeps coming up that people need to know about. And then some infrastructure is code tooling like Terraform, right? Or, we'll see where OpenTofu goes. But those are four pretty important things that the modern network engineer needs to know at least a little bit or more about. That's not comprehensive. That's not everything you need to survive, especially in the light of everything that Tom's talked about today. But, on the Git stool, there's so much more to dive into. I think there's room here for people who are really motivated and self-learners that will go into and they'll go dive into GitHub and suck it all up. But I think there's an even larger community that needs help, and so for things like Tom is doing with Kubernetes, right? Kate's coach and things like that, I think there need to be more of us that are willing to help kind of propose a framework and a plan for not just individuals, but for organizations. And that's something I'm really, really interested in doing. That's going to be taking up more of my cycles in 2025. And the three of us need to talk more about that offline. So
Well, anything you want to add, Tom?
I think the only thing I'd like to add is, the Katie's Coach is a passion project of mine, and I'm going to be socializing on LinkedIn these Katie's Coach streamcasts, and they're very, very good. The one with Scott was phenomenal. And so if anyone out there could just hit me on LinkedIn, and then you'll probably see the messages coming through. I'm going to be distributing them. I have 4 recorded already, and so I'm going to be distributing them 1 a week going forward. And there'll be a corresponding, really high quality blog and stuff. And it's just content for the community, and it is geared towards network engineers. And so yesterday I had a fellow on from GitLab who has something very similar to GitNops. And so we did a show on that. And I'm very proud of them. And if anyone out there is interested, they're good streamcasts and they're broadcast on LinkedIn.
Yeah, what impresses me the most about you, Tom, is these are all coming from a good place, right? Like if the listener's thinking, what's the catch, right? There's really no catch. Tom is just this passionate guy who's willing to help, who's always a team player, if you will, right? Coming from his sports background and all of that. And, just for example, I mean, tell us the Africa story that you have. I find it pretty interesting. And I think that kind of, puts into context of why you're so helpful and your philosophy around it.
Oh, thanks, Eric. Yeah, so I really do feel service is incredibly important to life, and that comes from my upbringing. I had a disabled sister, and then I was a Boy Scout for 6 years. Then I had an enormous keg party and didn't get Eagle Scout because of it. So that's a story for another time. But it was a legendary keg party. It was amazing. But anyways, so fast forward, I was working at Booz Allen Hamilton, and I had done a ton of wireless networking work, and I was able to get onto a HIV drug distribution project where I went to Africa, both East and West Africa, and Cote d'Ivoire and Tanzania, Arizona, and I taught the local people how to build long haul wireless networks. And the reason is that the cold HIV drugs need cold storage, and you have to have a really, really good tight supply chain that needs telecom in order to do it. And
Right.
it's the thing I'm most proud of in my career. I was there for 6 months. I was in the bush. I got surrounded by lions while I was there. That's a story for another time. But wow, it was really tremendous. It was an amazing experience.
And to me, that story just signals how you approach life, right? And how you approach the rising tides raises all boats type of thing. So, and same here. I think the three of us are on the same boat where we think community service is important and helping others will eventually come back to you, maybe not immediately. And, that's why I'm proud of too, what we're doing here. So, I mean, we're coming up on time. Do you want to tell us where people could find your work, Tom, if they want to follow more of the Katie's Coach, and where can they find you?
Yeah, so I think the best possible place is Katie's Coach. My email is tom@katiescoach.com. I'll put a link to my LinkedIn up on Katie's Coach, and then I would love to connect. And from Scott's podcast that I did, I've had a number of people reach out to me, and I've had virtual coffees with most of them, including you, Eric. We got it together in person, and then we're going to be hanging out soon as well. And it's just been a tremendous pleasure being a part of the community, and I'm really just thrilled to be here today. And thank you very much.
Ditto. It was great. Actually meeting in person in this day of age. What are the chances, right? I was like, oh, this guy's in Boston. Let me go ahead and reach out.
We've tried. I actually came up to New England and I think we're 0 for 2 on trying to get together. So I'm jealous. I need my Dunkin'. So I need to come up and have some Dunkin' with you guys. So.
And some lobster. And yeah, so Scott, thanks for being here. And it's a pleasure to always co-host with you. So where can people find more information about you? Obviously, you're very famous in the network engineering community, but tell us more.
Please find me on LinkedIn, Scott Robon. If you can spell it ROBOHN, that's the best place. And don't forget to check out Total Network Operations when you're not listening to Network Automation Nerds or other streaming things from Tom.
Yeah, it won't offend me if you listen more on TNOps than Network Automation Nerds. Honestly, just it's a great show. And that's how I learned about Tom. I learned about a bunch of other, and I saw the pipeline. It's great. I'm looking forward to many of these interviews. So thank you both for being here. Thank you, the listeners, for listening to this episode of Network Automation Nerds. If you have any feedbacks for Network Automation, our guest Tom, my co-host Scott today, or this episode, please send us some follow-ups on packetpushers.net/FU, where FU stands for follow-up, of course. We really do want to hear from you. And check out our website at packetpushers.net to find other network engineering focused podcasts, blogs, YouTube videos, and so much more. You can find podcasts such as Network Break for weekly shows, Heavy Networking for deep dive, Packet Protector for security, and much more, including Total Network Operations, of course, right? And thank you today, our listeners, for listening. And remember, last but not least, too much network automation will never be enough.